problem has three boxes, which I'm calling M1, M2, and M3, and they're on a level surface and they're being pushed by a force F. Now they're asking you to find the contact forces, the one in between the first two boxes and the one in between the second two boxes. In order to do that, you're going to need the acceleration of all three boxes together. And the easiest way to find the acceleration is to pretend that all three objects are stuck together with super glue and that they're all going to move together as one object, which they are. So to do that, I would just make one free body diagram of the three objects together. So I would have big mg, where big M is the total mass, normal force on all three objects, and then this force here, F, pushing them forward, right? This force there. And then when I make the x equation, all I have is that big force is equal to the big mass, m, times the acceleration. These equations can also tell me that the normal force minus mg is equals to 0, but I don't even need that. Since I know what the big force is and I know what the total mass is, it's really easy to find the acceleration of the whole system. The force that they give you divided by the total mass. Now that we have that, we can look at the free body diagram for M3 to find this contact force. Because that free body diagram goes like this. M3G, we got normal force on M3, and we have this contact force F sub 2, 3. Right? So that's all we have going on here. So its x equation is F sub 2, 3 is equal to M3A. Now, since we know the acceleration, we just calculated it, and we know the mass, we can calculate this really easily. Then to find the other one, this force in between the first two boxes, now let's do the free body diagram on the middle box. Let's start over. Let's put it here. All right, so we have, understand, there. I'm having a hard time drawing. M2G, we have the normal force on the middle box. We have the contact force from the left is coming from box 1. That's F sub 1, 2. And then we have the contact force from the right box, from M3, is going backwards. So that's F sub 2, 3. So the x equation for this box is going to be F1, 2 to the right because it's positive, minus F2, 3 to the left because it's negative, has to be equal to M2A. And since we know the acceleration from this calculation, and we know F sub 2, 3 from this calculation, it's really easy to calculate F sub 1, 2. It's just going to be F sub 2, 3, which we already calculated, plus M2A. And there you go.